An explosive is detonated and it produces an impulse on a particle weighing 1 ton, which is initially at rest. And we're asked to calculate the compressed distance in the spring, which has the following stiffness, assuming no energy is dissipated. So first, using the impulse and momentum theorem, the impulse is the area under the force time curve, which is half the base of the triangle, converted to seconds, by the height, which is the force, which we convert to newtons. And this impulse is equal to the change in momentum of the particle, which has a mass of 1 ton, by the change in velocity. So because it's at rest, v0 is 0. And then once you solve for the velocity, we apply the conservation of energy, which is the kinetic energy minus the energy dissipated, which may be due to the explosion damaging the mass. And this kinetic energy is converted into elastic potential energy to compress the spring. So 40 kilonewtons per meter is the same as newtons per millimeter. And when this spring is compressed, the velocity of the mass will be 0, so the kinetic energy is 0. So since we assume no energy dissipation, so we ignore this, and then substituting the velocity from the impulse momentum equation, you can find the compressed distance of the spring.